welcome everyone. So glad to be back again with another session. Hope you guys are doing well and staying safe and taking the necessary precautions. This is Rashmi and I'm a community manager at Recro, working towards building an exclusive community for developers to help you get connected with like-minded people and build your network and grow professionally. And those who don't know what Recro is, let me quickly introduce Recro for everyone. Something is written here as well. But quickly for everyone's understanding, Recro is a developer-focused platform connecting developers with right opportunity by connecting them with fast-growing startups such as Curefit, Udaan, Swiggy, Dunzo, etc. So welcome back to Recro Talks, and today's session is going to be very, very special as today we have not one but four experts with us who are going to talk about best practices and emerging trends in Android. Let me quickly introduce all the guest speakers for everyone, and then guest speakers can go ahead and say hi to the audience as well. First and foremost, we have Niharika Arora. She's very passionate about technology, currently working as senior software engineer at 1MG, and she has been an active contributor for the Government of India's app called Arogya Setu. Niharika, you can go ahead and say hi to the audience.
Hi everyone, and thank you for joining. I hope you will enjoy the session.
Okay, and Niharika is also the host for today's session, so really excited for that. Next, we have Arnav Gupta, who is a product and strategy lead at Scalar Academy. Arnav has been working for years on Android and has previously been the head of Android team at Zomato and Target India. He is very passionate about mentoring and teaching programming. Arnav.
Hi everybody. Very excited to be here. Really looking forward to all the things we'll be discussing today.
Awesome. Next, we have Subrajyoti Sen. Subrajyoti is a Google developer expert for Android and an Android engineer at Keep Trucking, where he develops apps to improve the trucking industry. Before this, he also worked on apps to improve the experience of Indian investor. Subrajyoti.
Hi everyone. Thanks for joining in our weekend afternoon. I hope you enjoy the session.
Wonderful. Next, we have Filip Bebic. Filip is a senior Android developer from Croatia and a Google developer expert for Android and Kotlin. He is currently working on building awesome things with Jetpack Compose, teaching people about topics in Android and Kotlin and sharing his knowledge in various types of community engagement. Welcome, Filip. You can go ahead and say hi to the audience.
Yeah, hey everyone, and thanks for joining. And I hope you have a really awesome session. We're all super excited to talk about Android and all the awesome things. So.
Awesome. So thank you once again, everyone, to all the panelists for joining us today. I'm super excited for this session. Before we start, I have quick announcements that I would like to make to everyone in the audience. Keep your notepad handy, and whatever you learn from today's event, post it on your LinkedIn profile, tag Recro, along with all four of our panelists, and use hashtag Recro Talks so that we can find your post and we can reshare the same. You can also take the screenshot of the session if you love it, and again do the same thing. Post your learning and use hashtag called Recro Talks. So with that, we are all set for the session. I hope you guys enjoy and have fun and learn a lot from our panelists today. I'll pass my virtual mic to you, Niharika, to take this session ahead. Yeah, you can go ahead.
Before I start, our panelists start answering your questions. So I just want to make one request. Anytime you have any answer or anything, any doubt regarding any question, or maybe you want to ask anything, just keep answering those in the chat. I know you guys can't talk, but we want to see how much you know, and you can also share your learnings with others. And also we are also learners, so just share with us. So let me start with a very basic question, which I think everyone has here. So the question is what in your opinion would be the basic roadmap for Android development? So Arnav, would you like to take this question?
Okay, sure. I mean, this is something that I keep getting asked a lot because I've been mentoring people for Android development as well. And just because we're starting off, I would like to keep it really short and then just say that if you actually try to go out and look for, how do we get started with Android development, there's a lot of content out there today, which can get a little bit confusing. But in today's world, I think the guides on developer.android.com, which have gotten populated really, really well over the last few years, they feel like a great place to get started with. The only thing caveat I feel is that when people talk about, as a newcomer to the Android ecosystem, when we talk about a roadmap, like what are the things to learn, we have to filter a little bit for the bias for hype, I feel, because people who are in the ecosystem for a while, when they speak about things like, for example, today, on my Twitter, you'd find me talking about something like, say, Jetpack Compose, something new that has come in. I'm very excited about it. I will be using it. But as a newcomer, if you're just starting off with Android development today, I would not recommend something like using Jetpack Compose. But if you look at my tweets and if you see me interacting with other experienced Android developers, you might see that, they are all talking about Jetpack Compose. So, I should also start with Jetpack Compose. But today, if you're looking for a junior Android developer role in any companies, they're not going to be asking you about Jetpack Compose, because most of the established companies, they are still working with XML-based traditional views. They're working with them. And they don't need, even, for example, Kotlin knowledge. Now it has gotten a little bit necessary, but we have been using, I think people here in the panel, we have been using Kotlin for quite a while now, but I think in interviews, Kotlin has only started appearing for last 1 year, while we have been using it since 2017 or something like that. So look at what's established, what's getting used for a while right now. And then, try to filter for and see what are the big companies, what are the technologies they are using for a while, and not what they are starting off with. So for newcomers, I think you should learn the things which are established, which are not alpha, beta kind of things, which are actually stable. And if you look at some of the popular open source projects, like there's the Telegram's app is open source, Firefox's app is open source. These are some of the bigger apps which open source, they're available. So you can see those code bases as well, and you can see what are the things that they are using, and you can follow them.
Yeah, exactly. I remember we had a last discussion and we were discussing the same thing, like Compose shouldn't be like, the freshers shouldn't be just jumping over Compose only. They should learn the basics also, the XML, and also as Compose is going to be in production this year. So in next year, they will have some experiences also, like the success and failure stories of Jetpack Compose from bigger companies. As right now, it's not been adopted by, again, just maybe early startups maybe are adopting, or maybe some companies have adopted it, but not like the way we have XML till now.
I think Arnav really covered it well, especially like the part about hype. I've seen a lot of people see all the crazy, flashy new things, and they are like, yeah, we have to learn that. And sadly, the reality, as Arnav mentioned, is that you're going to apply to a job and they are not going to be using those things. Or you might be one of those new people who are trying to push the awesome new technologies, but you have to realize that very rarely the projects get worked on for only like a few months, and then you like ship them and that's it. Most of the time, either someone else gets that project to maintain after a while, or you keep maintaining for years. So this is something that's called legacy code, basically, but basically something that's been built before and you have to maintain. And it's very common that you'll find Java in code, not just Kotlin. It's very common that you're going to find different types of architectures, different types of technologies and approaches to building apps, because people worked on those apps 3 years. So my general, this might sound a bit, weird, but my general approach is that if you're starting and you know about a few companies that you want to apply to, try to look for the technologies that they use and try to learn them first. So maybe if it's like your first or second job or something like that, you don't have a lot of experience, you can get into the very first job and then start learning there and grow your experience. That's at least what happened with me. I didn't know anything a few years ago, and I got into my first job where I learned a ton. And basically, after I got the fundamentals right, as Arnav mentioned, it was much more easy for me to learn, things like Kotlin or maybe some other Android topics. It is going to be maybe sometimes even demotivating because you want to jump into Compose, but you really can't. And another thing that you can do in this situation is just try to work on your personal projects too. I know that someone mentioned that in the chat. Personal projects are an awesome way to learn anything. If you want to experience something new, you can try it in a personal project. It doesn't affect the production code base or your company, but if you learn something, you can share it with your company, like gradually introduce a new topic to the rest of the team, and maybe you will get composed into the production after a while. So yeah, just take it slowly.
It sounds like a roadmap, actually. Yeah, you guys covered many aspects. I think for freshers, they really need to know, actually, and they don't get guidance around this. The next question I have for Shubhrajyoti. So what is the most annoying thing you have find Android development, and how did you overcome it?
I think most folks would agree about the most annoying thing being the device fragmentation and the software fragmentation, where you have so many API versions and so many things change across API versions. You might implement this beautiful animation and then figure out it doesn't work on these two specific OS levels. And things like storage, something works on certain version, the next version it changes. And I don't really think there is a straightforward workaround to these. It's mostly when you face them that you learn from them, and you learn that there are these different things. There is no straightforward guide to know that these are the biggest things that might be different on different versions, and this is how you fix them. One thing we can do is using the correct version of libraries that always look for these versions of libraries called app compat, which actually, or now rather the Jetpack set of libraries, which actually backport a lot of the changes. So the Android team is working hard to ensure that whatever APIs you're using, they're consistent. But even then, you might face across a few issues where you don't really know why it's not working on this one particular OS level. And a part of it is just as you build more and more, you start learning about these different things. And that's when you get the experience that, okay, these are the things that might break. But other than that, using the Jetpack version of libraries, I think is the best way.
Yeah, I think everyone has faced it. And
Right.
We are just overcoming every day, every year, every month. But not you won't get a clear work around it. So yeah. And Philip or Anna, you guys have any other experience than fragmentation?
One thing, I mean, I completely agree with Shubhrajyoti, so I'll not repeat that part, but because I have been working with other technologies a lot as well, apart from Android. And one thing that does get frustratingly annoying with mobile development is the constraints on very high resource usage for developing these things. So like these days, the most used device that I have is that M1 MacBook. It's a very small device, and I can just pick it and carry everywhere, and it's quite a lot of battery life as well. So it's like 90% of the time that's the device that I'm using now. And you can do great web development, you can work on backends and a lot of stuff, but mobile development, it's you always need to have one of usually very costly and bulky devices. And then if you want to run your emulator, then there are even further constraints. So carrying around at least an Android device is needed. So and then most of the devices heat up a lot. Your battery life reduces a lot if without connecting to a charger. You have to do mobile development. And I've been doing Android development for almost 10 years, like right from when it came out. Since then I've been doing, and this problem has just kept getting worse. So today, as a mobile developer, you need very high resources to get started with it, which I feel is a bit of an annoying factor. You can't just quickly pick up a Chromebook kind of a device and start building things on it, which you can do with most other platforms.
Yeah, and also sometimes when you see any issue coming on production and you don't have the same device or the same API level within your team or with you, that's quite annoying. Then yeah. Yeah, Philip, you were saying something.
I was going to say, well, kind of in a similar manner. Basically, whenever you have something that's external, that's not specific to Android itself, there will be a lot of issues, or you might run into a bunch of issues that are based on other devices or other environments that you use. So, for example, if you're obviously working with a backend solution or something like that, or something that serves you data, you'll have to expect that there's going to be some back and forth there, because The backend team works on their code and like their environment, their code base, but it might not always be in line with what you can consume as an Android developer on your side. Another good example here, I think, is working with devices that use sensors or that use other types of information, for example, like Bluetooth and different types of connection. That can also be very flaky. It doesn't work very consistently most of the time, especially if you're like working with devices that have very specific measurements, that have very specific ways of storing information. Then you have to know how these devices work specifically, which is not generally like your job as an Android developer. So if you're looking to join, or like you're looking to work on some Bluetooth devices or IoT stuff, you're going to have to be like prepared to have some trial and error there, because there's going to be a lot of things that can go wrong, or a lot of different things that can work differently between two of the same devices, basically. So yeah, just be like mindful of different environments that you're working with, and understand that it's normal that not everything works out of the box when you write the code initially.
Okay, so next question we have is I think many of the attendees are asking the same question, like someone who knows basic Java and want to become an Android developer. So where should they start, and how they can learn step by step? So Philip, you can answer this.
Yeah, sure. So I'll just for a minute share my experience. When I was moving from like Java to Kotlin and things like that, or when I was moving to Android after learning some Java, again, a lot of what helped me learn is trying to replicate some of the Java projects in like either Kotlin or in Android, or if it was like a Android project written in Java, I try to replicate it in Kotlin. It's not important that you get the things correctly the first time, but you like write the best code, that you follow all the best practices. I guess it's important that it just works, that you get the sense of the language. And as Arna mentioned, there's a ton of content out there that you can look through to learn very specific knowledge in Android. I think both Safra and I are in one of these teams that produces content for Android development, so you can always check it out, and the content is free. We can link that somewhere later in the show notes or something like that. But yeah, you can just like Google, Android resources or Kotlin resources, or moving from Java to Kotlin, because what you have to understand is that you're not the only person who made this transition. There's literally millions of people, and because of that, there's not a shortage of content out there.
Yeah, true. And I think everyone has their own experience, and you can't just go with, if someone says that they are learning from video tutorials, or they are learning from blogs. Everyone will have their own experience only. It depends on you, like if you like reading more, or if you like just visualizing and then learning from those people. I think that again comes from experience only. Yeah.
I would like to add to that. So whatever Philip mentioned, just to add to that, we discussed projects earlier as well. But one good way I would say is, like, if you like know Java, you can write the Android code, but think of an app that you would want, or that might help you in your life. Or maybe you like an app that you would think that, oh, it's cool if I could make something like that. You don't have to make the exact same thing, but even if you can make a very simple version of that, and you can do that even if you know just Java. Just for example, you're making a note-taking app, and you want to know, how do I display the screen? Google that. You learn how to do that. Then you want to know, okay, how do I save this note in my on my phone? Google that part. So you don't really need to know the entirety of Android before you start making your apps. Because when you start following tutorials, you tend to do that. Like we go through like 10 or 20 tutorials, but in the end, we're confused, like, how do we implement this? So if you take something that you want to build and then figure out how to build it, the concepts will be much clearer, and you will get more hands-on experience at it.
Yeah, true. And also someone has asked, like, suggesting some free resources. So I think after the session, our speakers can post some links for that, like their best resources from where they can start learning. Okay, so as we talked about Compose also, let me ask you one question around this. So what are the best practices, like if someone has to shift from XML to Compose, and this is for a beginner, like they just know the XML part only.
I can just jump in real quick. There is a website. I'm not sure. We can find the link, but basically there is like a website that shows you XML or legacy, let's say Android alternatives in Compose. So for example, if you're looking to display an image, it will give you like the alternative to the image view in Compose. And you can use that to at least like see what the components are, what functions you have to call, and things like that. Otherwise, I would say that you like try to duplicate a screen in Compose. Try to follow some of the tutorials that Google has because they are really, really good. They are very detailed. And obviously there's like a ton of content out there. So first try to see what you want to achieve. You don't have to switch absolutely everything. You don't have to completely migrate. Try to build like one small part of the UI with Compose or one new screen, something like that. And once you get that done, then the next screen or the next small part of the UI is going to be much easier. And as you go, you can gradually migrate, similar to what you could do with Kotlin. Just like try to migrate one file, then after you migrate that file, you can migrate another file or a third one, and so on and so forth, until you have like a whole, let's say, feature done. And then you slowly move to maybe migrating the entire app, if that's something that you need to do. But you don't have to like completely switch to something new like that. That's generally the not the best approach, because you can lose a lot of information in the process. If you try to switch everything in the first place and you do it incorrectly, then you're going to get like negative behavior, I guess. But if you try to switch just one small thing and you realize that you maybe messed something up, you can fix that. And then the next time you're not going to have the same mistake, I guess.
Yeah, true. And any part you enjoyed by conversion? This like anything you found very easy? I know the animation and recyclable part, but anything apart from that?
For me, so I haven't migrated apps directly to Compose, so to say. I have some personal projects, but in my current work, I've basically like tried to replicate the things that we already have built in XML in Compose. So to me, it's just like visualizing how it looks in, or how it should look in the structure of the UI. And I just try to play around with Compose until I get that behavior. I think overall, it's much, once you kind of understand the mindset shift of not being very imperative, or rather building things declaratively, it's much more intuitive. Like if you show a dialogue, if there is some data for the dialogue to be filled in, you show a special option or a special button, or you enable a special button if the data is correct. Instead of having to like say these things imperatively on call functions, it's just state that's sent to the UI elements. So it's like much easier to build pretty much anything, or like much more intuitive for me. And as you mentioned, like the animation API is super simple. It's super nice, super easy to work with. But everything seems much more intuitive when you kind of work a bit more with it.
Yeah, correct. Next, we have a question around architectures. So I think there are many architectures again on hype, and people actually don't understand sometimes like why exactly we need an architecture in our application or code. So there are like MVI, MVVM, MVP, and clean architecture. And I think if I ask a question in interview, so I get an answer like MVVM is most recommended because Google is recommending that. So I know this question goes to you. Like there is a hype on, again, clean architecture, MVI, MVVM. What do you feel about it? And I would love if you can just talk about like why architecture is important and why should people incorporate at the very first point, not just going with types.
Okay.
Yeah.
Interesting. I have a little bit of controversial opinion here. I feel that when people are getting started with Android development, they should make a few apps without these architectures and actually make using that what we used to call God activities with MVC only, like write all of your code inside an activity. I think everybody should actually go through that phase once to actually understand the mess that you can create when you don't follow architectures. Because if you are coming in from a context where you have only worked with some very simple command line projects, that's what happens when, a lot of people who are getting started with Android, before that, they might have used Java to write some CLI based projects like find the average of 10 numbers or, something like that, or even make a parking system in Java. Those are, very simple projects. You have used 3 or 4 Java classes to build that. You don't really know that, and at that stage, if you, put a person into an environment environment where you force them to work on architecture, they just feel that the architecture is needless overhead, that you have to write a lot of boilerplate code and you don't see the advantages of that happening. Now, for example, with dependency injection, I have taught a lot of people Android development, and I find that, if you just actually make somebody go through the docs on the Dagger website about thermosiphons and coffee makers and everything, they're just gonna get, super pissed off, like, what the hell is this thing? Like, why do I need to understand all of that stuff? But if you show them a mid-sized project, and you show them that, okay, my network module has to be sort of used inside every repository, and then every repository is supposed to be used inside the view models. And if there was a more way more simpler process where I can just write, at inject network client, and I can get my network client automatically there. And there's just one common place where how the network client is created is defined. It's just like some bulb lighting up in their head. They see that, oh, okay, this is where I'm actually gaining in terms of, because when you're making your first, simple app, let's say like a Twitter clone or a, Medium clone or something like that you're building, or a to-do list app, and their network client is going to be used in only one single place in the entire app. So their dependency injection work is actually really overhead, because if you don't have dependency injection in that kind of a project, then your code base is actually much simpler. And at that scale, it's actually recommended not to use something like dependency injection, because why do you need that? Because you're going to be using that only in one place, but then you need it in 5 places. The importance starts getting visible. So create the mess 1 or 2 times, and then you see the advantage of actually having a proper architecture that I definitely mentioned. The second thing is, also about if you have only worked with Android and nothing else, then something like MVVM makes a lot of sense. While if you have worked with other platforms, then I feel that, a lot of people relate to things like an MVI kind of an architecture more, where they don't want to, entangle themselves with how Android works a lot, how the view lifecycle works, because MVVM is still an architecture that is built completely with the focus that there is that lifecycle problem that's going to happen, and that's why this architecture exists. But there are other platforms, other UI platforms, like when you're making web development with something like Angular, or you're making iOS apps. In that case, the lifecycle problems are there as well, but their life cycles are completely different from Android's life cycles. So in those cases, you would want to treat the view in a very dumb way. You don't want to deal with the concept of the life cycles and the scopes of the view, and you want to consider it as a very dumb sink of data. Those kind of people can find MVI to be a more intuitive, framework to sort of work with. So understanding that is also important. I think people should try out using MVVM, MVP, and MVI, all 3 of them once, and see which is the framework that they feel most intuitive to work with, and take a pick according to that. Also see which one they find best to test with. Like, I have done interviews, a lot of people say that MVVM is good because it is testable, and I tell them that the other frameworks, the other patterns are also equally testable. It's just the way you write tests, it depends on that.
Yeah, cool. I think you have answered it completely. So I don't, I think people would have the answer for all the architecture, and they can start implementing, understanding the use cases. Okay, so as we talked about unit testing, so let me go for another question. How useful do you find TDD approach to be used while writing code, and can you share your experience and the impact it has created? So Shubhrajyoti, can you go for it?
So when it comes to TDD, I'm not very strict on it, because you have to evaluate it based on what are you actually producing. If you, for example, working for a high growth startup, you can't really justify the initial overhead of TDD, because your first priority is shipping out the code base, and later on, I would say the engineering maturity comes. But if you're working, for example, a product where things are very stable and you can take your time to build out features in the best way possible, then you can use TDD. It's something that has this initial learning curve of figuring out, like, especially if you're not used to writing tests. It's a complete change of mindset where actually you write the tests first and then think of your code. But one thing I've noticed helps is if wherever you're getting your product specifications from, if they're very well structured, they help you with thinking about tests as well. Instead of you just getting a requirement that this is the feature that I want to build. Instead, what a lot of, I would say, product managers do is give you very good specification that as a user, I want to do this, this, this. And when I do this, I expect this. Now, in that case, working with TDD becomes much more simpler. So I feel it has its benefits, but you have to decide based on what you're building and what your circumstances are.
Yeah, true. Anna or Philip, did you guys have any kind of experience, or where did you find like TDD approach to be like people can have some examples for them, like they should go for it. They should be convinced.
Yeah, so I haven't personally used TDD very much. And I guess the reason would be that, like, for the most part of my career, I was working in like agency type of companies, which usually have this approach where it might sound bad, but like you're trying to build as many projects as you can. You're trying to like get a lot of income for the company. You're trying to grow the company and so on and so forth. It's like a circle of trying to grow the company, get more projects, getting more people in, doing more work, and so on and so forth. And in those type of situations, it's very hard to utilize TDD because you're trying to build things as quickly as possible, obviously. You're trying to make them good. You're trying to write quality code. You're trying to like do your best when building the app. But also in those types of situations is that a lot of things change very quickly. And you very often have very strict deadlines, which means that if you're writing tests first, that's going to take away some time, obviously. The code is going to be covered, which is great. But if the client or if the design of the project, I guess, or some of the features change completely, it means that you also have to update all the tests. You have to update them in a way that they still make sense and that you're not just like trying to quick fix or hot fix the tests, I guess. And you also have to change the code. So in those types of situations, I find that TDD is actually very restraining and it's going to take a lot of your time. However, if you're working on like personal projects or if you're working in a company where you're building your own projects or like your products, then TDD becomes much more likely to happen, and it's much easier to do something like that because you are building the product for the company, and obviously the company has deadlines, but it's also very flexible in that sense where you can get more time to contribute to tests and the testing environment and everything, so that the product that you ship as a company that's obviously going to help the company and you as a developer is as good as possible. So I have like very weird and feelings about TDD in general because I haven't had really great experience. Unlike maybe Suhrajoti or maybe Arnav, so he can maybe drop some more comments on that.
So I'll definitely share a couple my also 2 cents on the TDD thing. It's I think first of all, with platforms which have their own weird way of the UI getting rendered, which iOS is there, Android is there. Even I have worked a little bit on Mac OS apps and Windows apps as well, and they also have there. So real end-to-end TDD of the entire user behavior cycle is generally, I would say, like, let's be honest, it's actually impossible. It's not really possible. I mean, there are apps which do 100% of it, but then they are taking some assumptions. They are, covering over some flaky tests, and they are, basically, even if you're sort of doing something like perform click versus somebody actually clicking on your device, latencies of 200 milliseconds that the hardware layer put on, on the scroll flicking behaviors, those kind of things you can't actually emulate using TDD, right? So I feel that, I 100% agree with what Philip was saying, and I would actually take it a little ahead of that, is that even when you're working with an organization, if you are the one who is shipping the features on a product, TDD might not be so crucial to you and might actually hold you back. if you are creating SDKs, or if you are, internally in an organization, you are part of what generally are called platform teams. So you're building internal libraries for the rest of your team. So I used to run the platform team for a long time at Zomato, where we used to build things like the UI kit that the rest of the team is using, or the network kit that the rest of the team is using. So it's like being an internal library developer for the other feature teams that your apps using. Those are the cases where TDD is kind of important, and it's also easy to implement TDD on those surfaces because you're providing an API to somebody else to use. Like say people who are making the Jetpack libraries, actually, right, on Google, they are definitely following TDD. If you see the source code, you will see that they actually, a lot of places you will see the commits. They actually write the test, the black box test, and then they write the actual implementation, because they are shipping something that a lot of other developers would be using. So it's easy to programmatically test also what they are shipping, because it's not going to be consumed by users, it's going to be consumed by other developers. So there's going to be programmatical interface for that. And TDD is also important for those places because, in a 0.01 update on a Jetpack library, if there's a bug, then it becomes like millions of people tweet about it for the next 3 months when that happens. And then it's also very hard to fix it if the library is actually shipped and it's out there and it goes out in the wild with some apps. Then users would actually have problems with those things. So that's the space where TDD is sort of more important. Don't become somewhat like TDD fanatic when you're shipping products. Try to get as much code coverage as possible, but don't try to aim for 100%, or otherwise I will not ship or something like that.
I think even we had the same kind of experience, and I have worked in startups only, and we always get these kind of deadlines and have to meet the business needs. But for sure, you have to decide between the performance, maintainability, and how do you be performing with the code? Like if a new feature comes up, like if you be able to incorporate the things, and even a small, we actually had a very stupid issue which was encountered by our CTO, and we were like, we can't make a live, even if the QAs tested it, but sometimes it happens like some of the things can't be, we can't just be sure about some of the logics which we are writing, but maybe when we write tests and we are following the TDD approach, we will be covering most of the cases out there. But again, it depends on like how are you going for the code itself, and as the points you guys mentioned. Let me go to the async world then. So people, I think most of us are maybe using RX or RxJava or coroutines in our code. So people often compare RX with coroutines, and so the question is like, are they really solving the same problem, or are they really similar? And which one should we prefer, like implementing in our project? And so yeah, any opinion around this, Philip?
Yeah, sure. So they are kind of solving the same problem in terms of you want to achieve concurrency, or you want to achieve asynchronous programming. In a sense, you want to fetch some data and not do it on the main thread to block the user, and so on and so forth. However, the frameworks and the mindsets that you have in those two frameworks are, I would say, completely different. There are a couple of, I guess, reasons for that. First off, well, in RX, the whole paradigm is that everything is reactive, that you're going to have a stream of events that, and a stream usually means that you're going to have like an open pipeline where multiple events come over time, and you at some point you might receive like an event that says that the stream has completed or that something failed. On the other hand, coroutines, and I would kind of put flow aside. The very basic idea of coroutines is that it's not a stream, it's actually a single call, something that's, let's say, synchronous, or at least it looks sequential. And then you get some information back that you can show or use or consume. These are very two different mindsets. And for that reason, I would say that it's not the same. Additionally, coroutines are, they have the compiler, or like they are built into Kotlin, I guess. And there are many different ways that they work internally, and many different things that they use internally that's much more low level than RX, where a lot of things are very manual. And you don't see all these things in coroutines, but because you don't see them, because they are implemented in a low-level way through the compiler, you don't have to worry about a lot of these things. And the syntax itself is much nicer. So another thing that's like people do, as you mentioned, is that they keep comparing like RX and coroutines, and that you can like replace one with the other. And my opinion is that this is happening because RX in general has been misused a lot in development, especially when it comes to like API calls. When you think about it, an API call is something that you call, you send some information to the server and you get some information back. That's not a stream. That's essentially a single function call, right? But people kept wrapping it into things like singles or even observables, which don't really make sense. So you try to replace something that should be very intuitive to the user, something that's very easy to understand, something that's very low level, with something that's like wrapped in multiple layers, and you have to handle it. And because of that, you get into the situation, I guess, that we mentioned, where you have a lot of legacy code that everything is RX, even though I would say like 95% of it shouldn't be RX. In those cases, it's much easier to just use coroutines and just use like the sequential calls that make sense, are intuitive and easy to write. But there are still situations where RX can solve problems that basic coroutines can't, as I mentioned, aside from Flow. For example, I worked in a company where RX or Flow was mainly used because the whole idea of the product is that you have a single place that collects multiple pieces of information from multiple sensors. And those are streams of events. Like you get the sensor from your lights, from basically like a smart house solution, I guess. You get all the information from the smart house, and it's a constant stream. You constantly get new information. And RX and reactive programming there is something that you should use. It would be much harder to implement it with just sequential calls in coroutines. But you could do it with Flow, I guess. So in that sense, kind of to wrap my chain of thoughts is, whenever you have something that's very sequential, something that is not reactive, something where you ask for information and you get it. So for example, like things like fetching from a database or from an API call, then just use basic coroutines. If it's something that's reactive, you can use either RX or Flow, whichever you prefer. So if you're already in a coroutine environment, you can try to use that like Flow instead of RX, but otherwise you can choose whichever you like. So I hope that this kind of answers your question.
Yeah, okay, yeah. So one thing I think someone has asked, like, do you mean like using RX observables for API is wrong? So can you answer that?
Yeah, I think so, because as I mentioned, you're requesting it for the information once, and if you're using just basic HTTP, you're not going to get multiple events of information. You just get one, and that is not a stream. So you're adding overhead with a stream, which you shouldn't really be doing.
Yeah, true. We had one thing like there are too many updates with every Android version. So can you guys just tell like 3 biggest and most effective updates in the recent versions from Android 8 to Android 12? So can you just give 3 biggest updates around that? And how has that played a major role in terms of performance, security, etc.?
I have an unconventional, I would say not so popular change specific to how we do things, but I would say addition of dark mode indirectly has improved a lot of things. So normally you just think of dark mode just being a visual change, but internally when we toggle, I would say the theme, the light and dark themes, we are actually restarting everything in that life cycle. And that actually helps developers find out a lot of these edge case bugs that happens whenever we recreate state. And it's something very unintuitive that something like that actually helps us find all these bugs in an app. For example, we had a case where if someone toggled the app's theme, a screen would show up twice, one on top of other. So one screen would be half transparent and we could see 2 screens at a time. And without dark mode toggling, we would have never thought of this. And the other thing I would say is, not from a developer perspective, but in general, in terms of the ecosystem, the permissions are being changed. Instead of just taking a blanket permissions for everything, we're taking like very specific permissions for things. It helps both the users as well as developers to make sure that we build secure things instead of having blanket permissions for the entire app, we do very specific uses. And I think that's what's recommended as well, that unless you need something like location, don't make use of it. And the fact that now the platform in the background, I would say, denies permissions that haven't been used for a while. That's something I really like from the user's perspective. And other thing I feel going forward would be very useful would be scope storage, where apps can decide that we need only this specific part of the storage to use, and we don't really need the access to the entire disk, and hence we don't really have to play on the permissions game. It's better for the user as well, because users are apprehensive of giving storage permission for the entire disk. Some of us blindly just click on allow every dialog box, but a lot of people are apprehensive as well. Like, do you really need access to all my files? But with something like scope storage, like, it builds user confidence, and it makes our lives easier as well, because users are more likely to give the permissions.
Right. Yeah. Even I think many of us haven't moved to scope storage till now. Maybe just for Android 10, we have done some changes, but not for Android 11, because I think people are finding it difficult to migrate from the storage structure we had, and now we will be having in future. Philip or Arnav, you want to share your the biggest updates you liked or not liked? Anything?
Sure. I can take up some of them. I think one of them was the move towards, I think 64-bit was really good, actually. So when that happened, there were a lot of libraries which actually use some native bits, and they actually went through a bit of an overhaul. Incidentally, like, there were a lot of problems with React Native that got improved because they were forced to get into 64-bit world, for example. So that is something that I really liked, especially for low-level libraries. That was like a, sort of Google pushing people that, okay, 32-bit we're not tolerating anymore. You have to be 64-bit only. You have to have native 64-bit support. That was something. The storage, so not just scope storage. So scope storage, if you just look at scope storage, it's like people mostly complain about the problems that they have when they're developing, but the storage storage framework API, that I feel is very transformational in nature. Now, there is a very, very, very old interview, I think an article where Sundar Pichai is talking about how files will not exist in the future, and I really like that his vision was when that was the time when he was not just CEO of Alphabet, he was not even CEO of Google, he was not even managing actually Android at that time. He was just the product manager for Chrome and Google Drive at that time. This is a very long back. And his vision was that file systems as we know it for the consumers might not exist, for developers it might. But when you go to Google Drive, you think of, okay, I have a sheet, I have a Word, I have a document, I have a sheet, I have a presentation. Today when you're using Google Drive, you still have that folder kind of thing a little bit to correspond, but you don't really have paths like you have on a desktop, right? Now, the reason is that, how we store files need not always be very file system dependent. Today, there are a lot of apps which have actually implemented the storage framework API very nicely. And if you try to share some images into it, Google Photos shows up as one of the possible places where you can share from. Then when you do Google Photos, you can actually pick up a photo which is on the cloud and you can share it on that app. Now, that's something that was not possible if you do it via the old method where you could only pick photos which are on your device. Now, the Google Photos, when they implement the storage framework API, or Dropbox also implements the storage framework API. So you can very transparently look at all your files which are both on the device and the cloud. And you don't really know which files are on the cloud, which files are on the device. You can just pick up any file. If it is on the cloud, on the fly, it gets downloaded and gets attached. If it is on the device, it gets immediately attached. So basically, you are sort of exposing a set of files. They could be coming from the network. They could be coming from the disk. That's really powerful, I feel, because now when you attach items and when you send something to one app to another app, you have access to a lot more data, which is all your data. But if you only go via the file manager, you have only the data that's on your device. And as things go more cloud native, as people actually use apps like Google Photo, where partly your data is in the cloud, partly it's in the device, storage framework API is sort of really, really helpful. And the permissions, of course, I definitely think that, as developers, we can rant about it, but as developers, we also are users. It's great that the operating system is working towards protecting privacy. So I think as developers, we should take up that responsibility and not think of it as roadblocks, but think of it as safeguards and work around them and work with them.
Again, we came to security. So we're moving to another security question. So security has always been a concern for Android users, and being an Android engineer, what do you think about how the framework has evolved, and what are the best security practices you would recommend the developers to follow?
Sure. Actually, I think so. Security is generally, I think, quite misunderstood topic as well, and for young people, it could be very confusing. But I think when you're starting off to build initial basic Android apps, unless you're making something where you need to protect stuff like DRM, protect streaming video like Netflix is doing, or you are making a fintech app where there are compliance based data protection things like if you want to locally store your credit card information, it has to be one way encrypted. Those kind of compliance issues are there. Before that, I would say don't try to think too much about security, but just if you don't do too much weird stuff with security, your apps are generally secure because the platforms, the frameworks actually enforce a lot of security onto you. I have seen examples and I have consulted as an advisor to a lot of apps. Is that a lot of people trying to roll their own security systems actually end up making a lot of insecure things. Right, we will do our own encryption. These kind of things that people try to do, they actually try to end up doing more insecure things. Okay, I believe that one aspect where security generally takes a hit is when youngsters are learning. A lot of the learning resources, they simplify things like we are storing passwords, and in a tutorial it shows storing as strings because they want to skip the step of showing that it is hashed and it is stored. If people who make content and they're teaching, and I really try to do it as much as possible, is that whenever you are sort of circumventing a step which is needed for security and you're doing it for ease of use and you're showing a very simple step when you're making a beginner tutorial, you should put a small asterisk, you should put a small box there if it's written content, or if it's video content, you should just sort of take a small detour for 20 seconds and say that, okay, this is not how we do it actually in production. In production, we do XYZ. This is just for demonstrating, we're showing it so that it's there in people's mind all the time, which is kind of, important. Otherwise, I think, REST, I think one more thing about security, I feel is don't go for overkill on the client side, because on client side, it is not really possible to have any kind of bulletproof security. I feel a lot of people waste a lot of time in trying to think that, okay, what are the ways I can, prevent this and that, and so many things. And I used to remember that, it used to be very easy for me to sort of, do, if I have to just extract data from the API or something from an app, I used to run custom versions of the Android OS itself, right? So cyanogen mod kind of things, right? So at the network level, like at the IO driver level of Java itself, you can make all the API calls log the data out. So any security that you put on the app layer can be easily defeated if the OS is under the control of the user. So a lot of people try to secure the app from the user, and that's where I feel it's a defeated battle, because you can't protect the app from the user because they are running on a platform which the user owns. They can run on a custom operating system. They can actually change how activity.java works, right? They can log out lines, they can sort of change how onCreate works. And your app is going to be extending that onCreate function, is going to be calling that. So no need to try and, sort of overprotect things at that layer, right? Just sort of follow the best practices. Don't take shortcuts for ease of use. That's it, I guess.
And I think there's one thing, it's difficult. It's not impossible, to reverse engineer any code you're writing on Android. It can be difficult, but again, people have NDK, or people are using securing the keys with code with ProGuard or anything. I think we can just reverse engineer everything which is there in the code.
I was working on this fintech application where you had to support a few things through web views. And it's when researching that I figured out that web views can be like very vulnerable, even though just seem very simple that you just open a web page. What more could happen? Like everything else you're taking care of on the client side. But that's, I think, one of the like most forgotten parts of security, that you are loading up a web page uh, and you can do a lot of things when opening a web page. And it's even the tooling system will warn you when you're enabling JavaScript on a web view that it can be insecure. So, I've seen a lot of apps just use web views very casually, like just randomly load up things in a web view. And that's something we should be at least a bit careful of, that when you're loading up a web page, you're bringing up a lot of the web vulnerabilities into your app as well, depending upon if you're validating your URLs or not, because someone can inject code through the URL, or when someone's loading up JavaScript. So try to use web views only in controlled environments where you know that you would be specifically opening your URLs, which you can secure, and not just any URL, sent by someone else. Like if it's some sort of a social media thing, if someone just sends you a very malicious URL and you try opening in a web view, it can potentially take over your app. So that's something I wanted to like just point out there.
Yeah, I had an experience with web view also for the security part. And again, you get that warning also whenever you are writing JavaScript enable there. But people do SSL also, like again, but SSL can be done if you want to do on Android side. That can be done on the first screen where you have the control. In other parts, I think the front end guys who are implementing the web view thing, so I think they have to put a lot of efforts there. But yes, that can be done. But yes, some tricks has to be implemented there. Very hype question nowadays. Like, what would be the role of KMM, Kotlin multi-platform, in future mobile development?
I haven't used KMM currently. I have dabbled in it a bit, but I haven't built any apps with it yet. But I think the idea is the same as, and I think the question is like comparing it to Flutter. I think the idea is kind of the same of where every single platform is going nowadays, or a lot of platforms are at least, where you just want to like reuse code. You want to have the same business logic. You want to spend as little time possible to get a product out and get a product out on multiple different platforms. In that sense, like if your question is like, if someone is asking if they should use one or the other, there is no clear answer to that actually. Like you should use what you think is the best for you. You should use what you feel the most comfortable with. If you're an Android developer coming from a Kotlin environment and you know Kotlin and you really like it, then I would say that KMM in general is probably a better solution for you than Flutter, because it's a whole different language, it's a different environment, different ecosystem, and so on and so forth. Vice versa, if you're coming from a Flutter dev standpoint, then I think you can just stay in the same system and try building more solutions on different types of platforms. The role, as you asked, of these platforms is just to try and unify the language, try to unify the platform, because nowadays, if you have dedicated Android teams, if you have dedicated iOS teams, if someone from the iOS team or Android team, let's say, goes away to a different company, or they go onto a vacation or something like that, and they own a portion of the code base, you are one person down in that team and you can produce less work, or like less value, I guess. But if you had one team that's pretty big, that is very versatile and uses the same platform, uses the same language environment, so on, then if one person goes away to a different company, or one person goes away on a vacation or something like that, then you have the entire team to fill in that spot, and you can more easily share the load, I guess. So that's kind of what the idea is. Now, with Kotlin multi-platform and the mobile part of it, there's like a lot of, I would say, things that are still not 100% clear, because like a year or something ago, it was aimed to just share code between, or like the Kotlin native project was aimed to just share code between iOS and Android, the business logic, the data classes, and so on. But then like a year later, it became a whole different thing where now you can build UI in it too. You have the desktop compose thing that's also viable. So it's growing and it's shifting because it's a community-driven project, like anything that JetBrains does. So in that sense, I can't really tell you what's going to happen in a year or when it goes like fully stable and fully ready. We might not just see, it being ready for multi-platform or mobile, or it being just for a few platforms. We might even get like some extra things like, maybe game development in it or something like that. I'm just like throwing random thoughts, but it can be pretty much anything that they want to build and they are able to build with the system. So hopefully that kind of answers the question.
Yeah. And also, again, people have a confusion around like, should they go for KMM or should they go for Flutter? So even that has, they don't understand the terminologies, but as these terms are on hype, so they are just confused around it. So if you can help out them, like what do they follow? The KMM or Flutter if they start or?
Yeah, so in that sense, like it for me, it's really hard to say again. I think like with Flutter, you might not necessarily go into like the whole, I guess, multi-platform aspect of it. You might build mobile applications mostly, even though you have the support for everything else, but it might limit, like in the job search or like the business perspective, it might limit your abilities, because if you're a Flutter dev and you're trying to build multiple things, it's very unlikely, it's very unlikely that you're going to build web applications with Flutter for your work. I mean, it's totally feasible. You can do that. You can also do desktop applications, but most people will probably like have you use or build the mobile apps. Whereas on the Kotlin multi-platform side, if you're going for the whole thing, then I think the context of it is that it is aimed for multiple platforms. So I think it might be easier to let's say persuade the company, or it might be easier to find a job that actually requires of you not to build just the mobile apps, but something else. But again, it's like Flutter is much more stable. It's been out for a long time, and there's been many applications built with it. Whereas the Kotlin multi-platform part or the native part and all that, it's not as stable. It's still being developed and all that. So that itself is going to hurt you in terms of business opportunities. So if you are looking to like try and build a multiple or multi-platform apps, then I think Flutter would be the easier choice. But again, bear in mind that you might just end up being, let's say, a mobile developer instead of building both desktop apps and web apps and pretty much anything that Flutter allows you.
Yeah. I have been asked this question many times, and now I'll be adding your answer to that. Thank you. Okay, so one last question from my side, and then I will pick some questions from the Q&A part. Like, as with Android, one can't cope up with everything because we are getting libraries, framework deprecated and updated every year, every month, and sometimes every week. So asking this to all of you, what would be the ideal way to learn and experience what's best in the market?
So the way I recommend and what I follow as well, that whenever something new comes out, I just go through what it's planning on doing or what its goal is, and if it's going to affect things I'm working on in the near future. So if something comes up that can be beneficial, for example, my work project, I will put it on a priority that this is something I need to learn. But for something like, let's see, multi-platform itself, we are not going towards multi-platform anytime soon. So I don't really need to start learning right now for something that might happen much later on. But rather the things that can affect my app, for example, we are right now building a design library. So if you can use Compose there, it'll be very beneficial. So Compose is something I'm picking up right now. So you don't really need to learn everything that comes out there, but you rather need some sort of a framework to prioritize what you want to learn. And it can be different. Like, for example, if you're just building out a lot of projects on your own, what are the kind of things you're going to build first and learn based on top of that? If you're a working professional, what are the things you might use at work down the line? Like maybe right now, a few weeks down the line, or maybe 2 quarters later, since business thinks in terms of quarters. If it's something 2 quarters later, you could just learn it that time. And given how quickly Android is changing, it's quite likely that even if you pick up the thing right now, and by the time you actually start using it, the framework either would have completely changed or partially changed. So in that case, you are just like doing actually a lot of incremental learning, and well, the previous thing becomes absolute at some point. So learn things that you need to, but at the same time, not saying that you shouldn't learn things that are fancy. If something really interests you, go ahead and learn. But if you really want to learn more, you have to learn to prioritize what you want to learn.
I think I've spent a lot of time now, and I think that the core essence of it does not really change as fast as people think it changes. The actually is the fancy stuff which changes more, because it's also, if you buy into that hype thing again, if you buy into something when it's at during its hype cycle and it's not actually getting used, it changes a lot, because the philosophy with what it started might not resonate well with everybody. Like, there are a lot of times early adopters and who might say that, okay, we really like the way this is proceeding. And a couple of examples from that, there is, I think, KMM itself, which started off actually as KMP, which was just Kotlin multi-platform using just the logic of Kotlin everywhere. And now they want to actually make it a mobile development framework and basically be an alternative to Flutter written in Kotlin rather than Dart. So that's the kind of direction they're taking, but their original direction was very different, right? And then sort of the community and the team around KMM is now, I would say today, kind of neglecting the people who wanted to just use it as a business logic piece while write the entire UI on their own on Android, and then because their UI side, they're marrying it a lot to Compose, and they're starting off with frame design patterns which use KMM with Compose together. Now I know a lot of shops who have been using KMP when it just came out, and they were just writing business logic with that while they were doing the UI work separately, right? Will they be continue to support? They might have to change things. Similarly with Compose. So when I first used Compose did not have what today we call Compose UI. It only had the Compose compiler. So you were actually using Compose as a DSL for existing Android views. I made an app like that. It's long back. It's almost 2 years back, when Compose was like not even a technology preview. It was just open source. Google did not even say that they are building something like that. Like, people just found out it's there on Google's Gerrit server, and people started using that. Now from there to now, Compose does not promote that way at all. Like if like my old app, which uses Compose only as a compiler, there is no tutorials about how to use Compose as a compiler anymore. It's all about how to use Compose UI, right? So those things you feel like, things that keep on changing and have to move. But say, the kind of architectures or the patterns or the concepts that we're using in a long-running app like Zomato's app, which was 10 years old, or Target's app, which was 6 years old, they're using a lot of concepts which have been there for 5-6 years, and they're still going to be there for 5-6 years. And when you're actually working in a big app with a lot of people involved and there's a lot at stake, you actually are very averse to using these new things, because that the stability implications and then the cost of switching is high. So, for example, at Zomato, I know we were using very few libraries. Even we were not using Dagger as dependency injection or RxJava. In fact, we're using a very simple set of things, because it's easy to get new people on board in that case as well. You don't have to change things when things change too much as well. And as you see bigger and bigger projects, they would use lesser and lesser variety of things. They would be really sticking to the core stuff, and that stuff changes a lot less. So when you're learning, I think if you also stick to the really essential core stuff and focus more on the projects that you're building, rather than putting a checkbox on how many new libraries I know, that's a better way of going ahead, and you would not feel the world is changing so fast if you do that.
True, yeah. And Raghav has asked the same question. Like, he knows, like, conceptually the dependency injection, but again, he finds it hard to incorporate in his code itself. So how do you suggest for the people, like, some frameworks or libraries are very difficult to understand? I think Dagger is on the top of that. So I
think with Dagger, I have a very simple statement I tell everybody. Like, if you're finding Dagger difficult to understand, then you probably don't need it right now, which is a very good check for whether or not you need Dagger right now. And I used to, I remember like that whole thermosiphon example, which is like very notorious. And I have visited that website. I think first time I did when, 2013 or 14 or kind of time, and Dagger 1 was available, not Dagger 2 actually. And then I visited, I think back in 2016 or so. And then once again back in 17. And when I visited that, Dagger's concept in 2013-14, I felt like I have no clue what this is about, and I don't know the problem this is trying to solve. So in 16, I think when I tried to see it, I felt like, okay, I'm understanding what they're trying to do, but I don't know why they're doing it, because that's a lot of work. But by the time in 2017, I tried to try dependency injection once more again. And then I realized, oh, okay, this solves quite a few important problems. And I see why they're getting it. And this is the same thing I teach web development as well. And I tell the same thing for people who are using Redux or any of these data management pattern like Flux patterns and all of those things. And I say that, if you feel this concept of how data is managed too difficult to understand, then you probably are working with projects which don't have a data management problem. So you just store your data in your views. That's fine. You're making a to-do list app. Why do you need two-way data binding and, syncing and, all that stuff? You don't need it. So you are not able to understand it. The day you actually are into a pickle, which Dagger can solve, you would also understand Dagger's documentation as well. I think that's a good litmus check.
Yeah, true. Agreed. Philip, your thoughts on this? Like, what's the best? How do you cope up with the Android things happening?
Yeah, I guess what Saprajati mentioned is that I don't really. So I'll clarify what that means. Basically, as Arno mentioned, if you know the core stuff and you know it well, then anything else, well, we can also dilute that back to programming in general. If you know programming, if you know the general concepts, the algorithm concepts, the data structures, and so on and so forth, the very basic stuff and how things work, moving from one programming language to another is infinitely simpler than learning the very first language that you do, that you want to use, or the very first time you start learning programming. That's something that is the same in Android with all the topics in Android. If you know Android well, if you know the core concepts, if you know how the system works, how the lifecycle works, and just in general how the platform operates and how things are being sent around, then any new framework, any new fancy thing, anything that's being added to the existing set of tools is just that. It's another tool. So for me, for example, I've never used things like, I haven't really used things like sensors and Bluetooth and all that part. I have friends who have, and I'll never learn that until I actually need it, like Saprajat mentioned. And when I do need it, it's going to be much easier for me to learn it because I have set year of experience before that. Same for Compose. I used the Android toolkit for years, and then when Compose came out, it was a mindset shift, but it was much easier for me to learn than if someone just started with Compose. Same with Kotlin when I switched over from Java. So again, my advice is that just like Arnav and Suprajoti mentioned, don't buy into the hype so much. Don't learn every new fancy thing because you think you have to. I would bet pretty much anything that there's not a single person on this planet that does Android that knows absolutely every bit of Android. Anyone who works at Google, even the people who have been working on it for years and actually developed Android, they still don't know every single bit of it. I'm totally sure that's true. And that's just the situation. You don't have to know how to use everything. When you do, you're going to learn it. So just stick to the fundamentals, to the basics, and make sure that the concepts that you do use, that you do know, and that you need for work, that you understand them well, and that you're not just using them without really understanding what's going on.
Okay, so Shri has asked any API did you find which with no bugs and which is super interesting, and you can just say Android has done something really great. Any API which you find perfect and with no bugs. So do you find any API? I don't think I remember anything like that.
I think intents, I would say. I really love intents, the way intents work. So, and the measure of something being perfect is that it does not change for a long time. Right. I recently saw a video about the PlayStation controller. So while all other controllers in the world have changed a lot, the PlayStation controller in the last, I think, 12, 13 years has not changed the basic design because it just works so well. And I think that that's a good test that you can apply on APIs as well. If they don't need to change, look at SQL. SQL obviously is a great design on storing data because the query syntax and all has not needed to update a lot, right? So if you put that test to intents and a lot of front end frameworks, whether it's something like a React, Views kind of things, or whether it's iOS, they don't really have something as good as intents, I feel, which is a super powerful thing that Android has. Across the app, from one screen to another screen of your app, from your app to your, from a activity to a service, like inter-process communication is super, super hard when you actually try to do it in places where it does not exist. And intents give you IPC at such a cheap cost. You just set up a data and action and you throw an intent, and people don't realize, because if you have to do IPC by hand in a backend project where multiple services are running, it's super hard actually. So intents are really perfect, I feel.
So someone has asked one question around the Android libraries, like what are the best practices around how when someone is implementing Android libraries?
Sure. So I'm guessing here Android libraries will be more like things like SDKs, or whenever you create these new modules as libraries. So the first thing I would think of is you have to start thinking not as both as a developer as well as a user there, as in you're creating code that other developers have to use. So you have to shift your mindset in a way that I need to write code that I would like using. For example, something that should be intuitive, or how the things are structured. Not just features where just users interact with you, but this is specifically for developers. So things should make sense. I mean, the way you're writing your methods, they should be intuitive directly. And I mean, documentation should exist, but I shouldn't have so much confusion around the method name that I have to go to the documentation to find out what it does. And also have I would say, well-defined surface area, or I would say contract, that these are the specific things that the library will do, and this is how it does it, and have those like defined methods, instead exposing everything from a library, which kind of beats the point of the library. Like there should be a well-defined surface that this is what my library's responsibility is, and this is where it ends. And this is what it will do, and structure in such a way that it doesn't change too much. Because if you're trying to do too much with a single library, it will just keep on evolving with every change that you do. The method names might change, the way it works internally changes. But rather, when you're creating a library, think of the specific use cases and try to restrict it to it. Because like I mentioned, right, if something changes too much, you wouldn't really consider it that stable. If you see most of the libraries out there, the only times that APIs might change is when they go from like version 3 to version 4. But from 3.1 or like 3.0.0 to, for example, 3.4.0, the APIs should be more or less same. It's just that there'll be bug fixes or improvements.
Cool. Okay. So I think questions would never end. I can see more than 100 questions asked, but I'm super happy. Like if you guys can also see, like people have already answered many questions there. I know audience is super intelligent and knowledgeable. So I think, but some of the questions, if they are, you want to ask, maybe you can follow us on LinkedIn or Twitter, and maybe you can get your answers there. And also for the resources. So we keep sharing resources, and I think that would be helpful for you. So now, thank you, Shubhajyoti, Arnav, and Philip. I think you answered very well. I think I have got many learnings from you guys. So thank you for that. And I hope our audience has also got the same thing. So now over to you, Rashmi.
All right. Thank you so much, Arnav, Philip, Niharika, and Subrajyoti for this awesome session. We planned this session for 1 hour, and we have crossed 30 more minutes. So thank you so much once again for sharing such insightful tips. Looking at the comments and looking at the questions, I can see that, it was really insightful, and audience also loved it. Also, we have created an exclusive developers community on Slack. You asked around 101 questions. We won't be able to answer all the questions here because we are limited by time, but you can join the community and you can connect with fellow Android developers and ask your questions there. The link is in the chat. Also, just a quick announcement for everyone that Recro is hiring some talented developers. If you want to be a part of the team, you can check out our careers page. The link is in the chat again, and you can follow us on social media to stay updated with events like these. I have also shared the LinkedIn profiles of all our panelists. You can follow all of them on LinkedIn and make sure, you also share your learnings with us. Take a screenshot if you have not taken yet. Share it on LinkedIn, tag all our panelists, and we would love to know your key takeaways from the session. On that note, I would like to say thank you again to all the panelists for joining us and taking out the time. And thank you to all the attendees as well. Hope you had fun. Hope you learned a lot. And I hope to see you guys in the next one. Thank you so much once again, everyone. Bye-bye and take care and stay safe.